Good morning everyone. In this video, we will talk about what NoSQL databases are and how we can enhance the security of NoSQL databases and hybrid security approaches. So, talking about myself, my name is Bhavik Talwar and I am a first year student at Chitkara University, which is situated at Rajpura, Punjab. So, first of all, we will look at what NoSQL databases are. So, before 2000, we are having SQL databases which store the data in the form of fixed rows and column form. They have a fixed schema-based structure to store the data, but there is a main limitation of that because of the fixed schema, we cannot scale the data to a large amount. And then after the modern era came, we came up with a variety of data that includes semi-structured and unstructured data in the form of documents, images, videos, etc. So to store that data, we need a database management system. So we created a NoSQL uh, database system that offer flexible schemas and horizontal scalability for big data. We were having only four major key NoSQL models that are document, key-based, graph, and column family. In the document NoSQL model, the data is stored in the form of records. It is mainly used in IoT sensing-based applications, example MongoDB. The key value database system in this, there is a key which is mapped to certain values to store the data, and we used it in caching purposes. The graph NoSQL model is used to determine the relationship because it consists of edges and nodes that enables the relationship between the various nodes, and we mainly see this type of non-management system in social media platforms. Then the column family NoSQL database model, we store the data in the form of columns, but each column have dynamically different. They might have same columns, but it can have different columns to store the data as per the functionality of what a system requires. Um, to create NoSQL database management systems, there are two theorems. First is base model, that it is basically available. It has a soft state and it is eventually consistent. So talking about these three terms, first the basically available, it means that the data is always be available and it might not be that much consistent at that particular point of time because the data is being stored in multiple servers. So it takes time to uh, consistently store that, but it is basically available at all the states. Now, the soft state means the state can change automatically if any backend operations come, and it doesn't require human intervention. Such as if we take about the example of WhatsApp, when there is a single tick, then when the internet connectivity is there, the double tick came, and when the message is seen by the user, then blue tick appears. So all these states are being changed automatically in the backend, and it do not require any human intervention to change the state. Eventually consistent, as I said, that the NoSQL databases are horizontally scalable, which means we can work on it on multiple servers. So if not at a particular point of time, but eventually after any performing of operations, the data will be eventually got consistent on all the databases. Cap theorem states that out of consistency, availability, and partial tolerance, only two things we consider in forming our distributed systems, such as NoSQL database. Now we have our SQL databases also, NoSQL databases also. So, but in today's modern world, we require the application that consists of both because we are having e-learning platforms such as Amazon and any other also that require financial or banking services which require a fixed schema-based SQL database system, as well as for scalability, user performance, and user interaction, and looking about the past data, and then on the basis of that, giving a new data to the user, we require NoSQL databases. So combining both, we were having the hybrid approaches, which consist of various database management system all together to create our application. This is a literature review that I have considered because in this presentation I will particularly be talking about the security of the hybrid approaches because in the current scenario we were having the individual security techniques for the NoSQL databases, and there is no standardized security measurement technique which is used to measure the security of the combined system. So after looking at the literature review, we come up with these challenges, which are the multiple database models. that increase the complexity of security because each model is having its own security measurement factor, and there is no standardized framework across system. And the current models which we are having right now are fail to detect the breaches instantly because AI anomaly based system also detect the anomaly in the form of batches, and they do offline processing to check for anomalies. And it is database specific, it is not generalized. So these are the current security techniques. ML-based fraud detection, which is database specific, as I have said. There is no response to real-time breaches because the AI anomaly techniques also consider the taking the data in the form of badges. Privacy monitoring, if we try to increase the security of the system, then it affects the performance. And AI anomaly detection, which takes offline processing. So considering all these limitations, gaps, and current security techniques, I have come up with my proposed technique, which is hybrid anomaly detection engine. What this technique will do, it will tell them like along with the individual risk factor anomaly detection, it will also consider the overall generalized security factor of the system, uh, which will be very beneficial to us because if we get the initial prior warnings for the any risk detection, then it will be very beneficial for us. So how it will work? It will first capture the user activity, what query has been fired, what the time has been taken, and what is the frequency that is considered in running the query. First of all, that will be considered, and these features will be extracted to create our machine learning models, which will be specialized for each database type. This work is being done till now in the current researches. So, but what is unique in my proposed technique, it is that after specializing for every database type machine learning model, we will create a unified risk score. Such, for example, if we have set up the threshold for MongoDB and Redis NoSQL database as 75, 75 each, and they are having the risk factor to be 60, 60, then the system will not generate any sort of risk in the system. But if our overall risk detection is 50%, then if we take the average of these two by applying the average of these two, then it is coming out to be 60, which is more than the generalized threshold value that we have set. So what is the working here? The particularly the risk is not being detected, but if we take about general case, the risk can be there, and prior warnings needs to be given, would be given, so and it would be very beneficial for that for the like database administrator also to check for the anomalies and and take any action if any suspicious activity is detected. So how my proposed technique is considering the real-time detection. So it will send an alarm in the form of SMS or notification to the NoSQL database administrator or any database administrator who is working on that field, redefining the security of NoSQL. So we were having new challenges like traditional measures that I consider are inefficient for polyglot environments. Polyglot means like combining various database management systems all together to create our application or for the functionality that we need. HADE provides an adaptive monitoring across NoSQL types, and it enforces centralized and dynamic security. Talking about conclusion, hybrid security is very essential as we have seen in all the applications that we are working on right now. Most of them follow hybrid security approaches. It can be used in proactive defense, which can emerge and counter the cyber threats continuously. The monitoring can be done continuously. And if we talk about the future outlook of NoSQL databases, it is expected to grow a 25 to 30% common annual growth rate by 2028, which reflects ongoing innovation and adoption. Lastly, these are the references that I have used in creating my poster presentation. And this concludes my presentation. And thank you for your time. I am open to any questions.